Hello, myself, Professor H.K. Bhangare, Department of Electrical Engineering, SMD College of Engineering and Research Center, Yeola. I welcome you in video lecture series of Basic Electrical Engineering. So today we'll start with the introduction to batteries, this topic from the fifth unit. So batteries, all of you are using in our day-to-day life, the batteries. So what are the different types of batteries are there? What is their working principle? What is their construction? So one by one, everything will look in the details in the batteries. So today we'll discuss what are the different types of batteries. So batteries consist of two or more voltaic cells that are connected in series to provide a steady DC voltage at the battery's output terminals. So at the output terminals, there are two terminals to the batteries. One is positive terminal and another is negative terminal. And across that positive and negative terminals, we are getting a certain voltage. Now, how that voltage we are getting, so that is the question, and that we'll see in the next lectures. But the batteries consist of two or more voltaic cells. So what is there inside the battery? So it consists of two or more voltaic cells in that, and that are connected in series to provide a steady DC voltage. The voltage is produced by a chemical reaction inside the cell. No doubt it is a electrochemical type of reaction. So electrodes are immersed in an electrolyte which forces the electric charge to separate in the form of ions and free electrons. Now, what is voltaic cell? So it is simply a cell or a device which converts chemical energy into electrical energy. It simply converts the chemical energy into electric energy. And a voltaic cell consists of two different metal electrodes that are immersed in an electrolyte. Electrolyte is nothing but an acidic or a basic solution. So in that solution, the two electrolytic plates are immersed, and that electrolytic plates or that rods are known as electrodes. That metal electrodes are immersed in an electrolyte. The chemical reaction resulting from the immersion of the metal electrodes produces a separation of charges. So as soon as we immerse that metal electrodes in the acidic or basic solution, so chemical reaction starts, and that chemical reaction results in the separation of the charges. So the current capacity increases with large electrode sizes. No doubt, the current capacity of that particular battery depends on the size of the electrode. The negative terminal is considered the anode of the cell because it forms positive ions in the electrolyte. The opposite terminal of the cell is its cathode. So two terminals, that one is anode and another is cathode. So here we will observe the construction of the voltaic cell. The two electrodes, this one and the second, are immersed into the electrolytic solution, and these electrodes are made from the different materials, and both of which chemically react with the electrolytic solution in some form of ionic bonding. So the motion of electrons in ionic bonding can be used to generate an electric current. No doubt, whenever there is the motion of electrons, it is nothing but the current. So electric current produces. So a device constructed to do just this is called a voltaic cell or cell for a short. So we generally call it as a cell. So battery voltage output and current rating are determined. So the rating of the battery, we always speak the terms that the rating of the battery. The rating of the battery is determined by the elements used for the electrodes. So what are the elements are used for the electrodes that define the rating. Also the size of the electrodes used and the type of electrolytic solution. So that defines the rating of the battery means how much is the output voltage is there and how much is the current capacity is there. So that will be determined by these three factors. The first is elements used for the electrodes, metal electrodes, then the size of the electrodes and the type of electrolytic solution. So cells and batteries are available in a wide variety of types. They are using different and different shape batteries. So a wide variety of batteries are available nowadays in the market. So here the typical dry cells and batteries are shown in this diagram. So these primary types cannot be recharged. These are not able to recharge. Okay. Now, whether a battery may be recharged or not depends on the cells used to make up the battery. So charging battery and recharging batteries, the two types of batteries we are using. So charging batteries, we can charge it, but the batteries which cannot be charged, right? So that is use and throw batteries. A primary cell cannot be recharged because the internal chemical reaction cannot be restored in primary cells. A secondary cell is also called as storage cells and can be recharged because its chemical reaction is reversible. So as the chemical reaction is reversible, the secondary cell can be recharged again and again. Dry cells have a moist electrolyte that cannot be spilled. Sealed rechargeable cells are secondary cells that contain a sealed electrolyte that cannot be refilled. So that electrolyte cannot be refilled in sealed rechargeable cells. Now there are several different types of primary cells in use today, and that are carbon zinc dry cells are there, alkaline cells, zinc chloride cells, mercury cells, and silver oxide cells. So these are the different primary cells. They are in use in today. So one by one, we'll discuss later on the detail about these different types of cells. That is what is carbon zinc dry cell, alkaline cell, what is zinc chloride cell, how they are working, what are their uses, what is mercury cell, what is silver oxide cell. So all we will study later on in detail in our next video lectures. Till then, thank you very much.